Hello, everybody. Welcome to our session about secure and efficient container image management. Today, I'm Zhang from China R&D. I'm the chief architect of Project Harbor. Today, joining me with my colleague, project team, Stephen Zhou. He's also staff engineer of Project Harbor. So today, we'll show you how you can use Project Harbor to secure and efficiently manage your container images. So here's the agenda of today. First, I will talk about a little bit about container images basics. So how many of you have no container and container images? Can you raise your hand? Oh, cool. So many people know that, so I can go through this part quick. So let me try. So basically, a container, when it is running, it is like an application running on your operating system with some restricted privilege. And then when it is not running, it becomes images on disk, right? On disk, which means that it is a static files. So when we're talking about management container, usually contain two aspects. One is managing the running container, the yellow one, the running container. The other one is managing the static image, which is mean when the container is not running, they will become static files, and then a lot of management will happen there. So today we're focusing on managing the static part of the container lifecycle. So when somebody created a container images, you want to share with other people, they can just push or upload it to a registry service. From that registry, they will be available to other people to download or pull from their own host. And so registry basically is a repository for storing images. And also a registry service can be used to ship or distribute images for your applications. It is a very ideal places for access control and other image management. So today we'll show you how you can use the registry service to efficiently manage that. So a brief introduction about Harbor. Harbor is an open source project which is originally originated in VMware China as a side project. And we use that internally for a few projects, and it turns out very great, very good. So we decided to open source it, and now it becomes a worldwide project and then adopted by users everywhere. And it's now in the vSphere integrated containers, as well as the PKS offering, as announced yesterday. It's the Kubernetes offering from VMware and Pivotal. So here are just a few, quickly go through some of the key features. We have a user management access control based on RBAC, and also have LDAP and AD integration. We have policy-based replication, image replication, and notary for content trust and vulnerability scanning. I'll go through some of them in subsequent slides. So here's the adoption of Project Harbor worldwide. It is one of, by far, the most popular open source project of VMware, and we have 2,600 plus stars on GitHub and hundreds of users worldwide, and have more than 700 plus forks, which means that developers are using it, forking it, and using their code for their image management. So here just a list of Harbor users and partners worldwide. We have like Rancher, OnStar here in the United States, that they're using all this Harbor to manage their container images. Harbor is actually composed by a few containers. It's used in the microservices architecture, and you can see it can be quickly spun up by Docker Compose. It's very simple. And here you can see the purple one is the code by Harbor, the open source project, and the rest will be other people's code. We integrate it together inside this project. And one of the features that I'll be talking about is the image replication, which is the synchronization. This is a useful feature that many of our users really like. And the first is that when you set up a policy of the replication, it will help you to populate all the images from the source registry to the destination. Initially, it will have an identical copy from one instance to the other. And then when you have push new images to Harbor, it will be incrementally replicated to the other side. So in that way, it will have totally synchronized copy of a harbor in somewhere else. This is very useful and loved by many users. So I'll quickly talk about Project Harbor, and then I'll talk about a few issues that when you are managing container images and how you will deal with those problems. The first one is the consistency of images. Consistency means that if you have multiple environments in your containers environments, that you need to manage those images, right? In a dev, test, staging, or production environment. All these environments, you may have different versions of images, different issue tracking, problem tracking, troubleshooting. It's very important that you maintain the same or exactly the same images during all these environments, because your images basically are the application wrapped or packaged inside the container images. If you have different versions, for example, if you have a version in the development and then you have different version in your production, later on you will have problems troubleshooting or identify the culprits, right? So it's very important to maintain the consistency of all the images. So some people told me that if you have a Docker file, I can always use the Docker file to build the images. But using the same Docker file will not always result in the same container images. Let's look at this example here. So suppose you have this Docker file, very simple, right? You have Ubuntu, which implies that you always use the latest Ubuntu image. But when you build this image at different times, you probably will result in different Ubuntu-based image that you use, because the latest will not always refer to the same version of the Ubuntu. Then some people may say that I will specify a tag behind the Ubuntu. We say 14.04. That will probably give you some of the identical images, but the answer is no, because the Ubuntu, you will probably, even the 14.04, it will evolve over time, because people will patch it or will provide a different package into it. So if you track the history of this 14.04, you may not always result in the same images, right? So this is not even safe if you always specify the tag of a Ubuntu. And things like apt-get or curl or wget something, because it's pulling packages from the internet, so you cannot guarantee you always have the same images. And also the add, depending on the files that you at the build time, right? So the thing to point out here is that even you have the same Docker file, it is not safe to guarantee you always can build the same container images. So how do we deal with this problem? So the idea is that you would try to build it once in your CI or in your dev environment here. So for example, you have code changes and you run through a CI system, and then you result in a dev registry. And then you can replicate it or synchronize it to another registry in a test environment, so that you will have an identical container image to use there. And then after testing, you can put it into a pre-production or staging environment with another registry, and then you will put it in the production registry, right? This kind of a pipeline, which means that promoting images from different stage. So you will always ensure you will have the same container image across your environments, so that you won't mix that up. When the problem comes out, you will have a better way to find out the issue. The next thing I want to talk about is the security. So there are many aspects about security here in the container images. The first thing is that access control. So suppose you are an organization, you don't want to put your image into a public cloud like Docker Hub, then you will choose to put your container image within your organization to keep your intellectual property inside and safe, right? So in private registry will give you efficient for accessing it, downloading, pushing it, more efficient, and by using a private registry. Then after you have a private registry, you can apply access control on it. Different people should have different roles, like developer. Usually you can push or pull the read-write access to the images. For tester, usually they only need testing, pulling in access, which means the read-only is enough for them. And besides that, in the different environments, the access control could be different. For example, right, you have a dev test environment. Many people can access it because just like a playground, anybody can just enter it. But once you go to the production environment, you don't want everybody to touch it, right? So as few as possible, people can touch it, the production environment. So you will restrict access to that. So only a limited number of people can actually access the production registry. That's how we recommend people to do. And one more thing is that many organizations, they may already have user management systems such as LDAP or Active Directory. So they can just integrate those identity into the registry to assign the role-based access control there. So this is role-based access control RBAC. And here's an example how we did in Harbor. So basically all the images are grouped under a project. And the project basically you give you a namespace, like the project namespace in the URL of the image, you can pull or push based on the namespace of the images. And then we can assign user into the project as a member. Members can have different roles, right? If a guest role means that a developer or a guest role means that they read-only access, can only pull, and they cannot push to the registry repo. And then they have the developer role, which means they can pull or push. And then the admin is the project admin. In addition to the developer's role, he can manage users, right? Add people into the project and remove people so that they can control who can have access. In addition to this role-based access control, in Harbor, we also have anonymous access. For some of the basic public repo, like the base image, base OS, we can make it a public image so that people does not need to be a member to access that. We call it anonymous access. Besides role-based access control, there are other security considerations as well. The first one is the content trust. Content trust basically means that the provenance of the images, where does this image come from? Is it coming from people you trust? That's the people created is someone you trust. So this is the content trust. We call it usually implemented by a service called Notary. That means that when you push an image, the creator will sign it and store the digest into the Notary service. When the image is being pulled, the client will just pull by contents. The contents identified by the digest of the signer, so that the people who sign it, we can pull it by the digest, so that if the digest does not exist in the repository, then nobody can pick up and pull this image. By that means that content trust will ensure you that the content you get is always come from the trusted source that you can trust. And the other security aspects is that the vulnerability scanning. So just like we're doing the McAfee scanning, virus scanning in the operating system, that in the container images, you may be able to scan vulnerabilities based on the pre-public sources like CVE sources. In Harbor, we have connected to different sources to pull in the vulnerability database. Based on that, we scan all the images inside Harbor so that we identify the severity of each of the images to tell you this is a very severe one, high, low, medium, and so on. Then you will decide whether we will allow this image to be pulled or run in another environment. So the next issue I want to talk about is the image distribution. This one also, people may not notice it in the development environment, but once they go into production, they will have this issues facing this challenge. Basically, a registry is a place that you pull your images down, and actually it's like distributing your containerized application to the runtime environment. So suppose you have a very large cluster of container hosts, then if everybody trying to pull the images together at the same time, they would run into a problem like the bottleneck of I/O of the registry, or the networking will become a bottleneck. So everybody become very slow because you are congestion there, right? So in order to solve that problem, we are having a scale-out architecture for the registry. That means that you can have multiple instances of the registry sharing same storage or sharing no storage. In the interest of time, I can show you one of the architecture that we did for some of our users, that they are using Harbor and Replicated to a second tier of registry instances, so that their container hosts can pull from the second tier of registry. So like in the diagram here, we first push the image to the upper level of the Harbor, and then we'll replicate it or distributed image to a second layer of harbor, and then all the Docker hosts can pull images from this harbor. It's like a load balancing and works very well for distributed, geographically distributed clusters. And here is that harbor can support multi-layer. We call it hierarchical image distribution, so that you may have a central registry in the headquarters, and then you have another instance in a provincial of a state level, and then have another at city level, and so on, something like that for the replication. So before we went into the demo, we have a demo by Steven. I'll just quickly summarize what I just talked about. Container images are a static part of the life cycle of your container management, so it will become a very important part that you may need to consider. And the registry is the key component that can help you to manage it for efficiency and security purposes. So the next one, I want to let Steven, our staff engineer, to show you two of the demo of our Harbor registry, and then you want to have a better understanding of what it is and how it works. Steven.
Thanks, Henry. Oh, okay. Thanks again for attending our session. This is Steven, staff engineer of VMware China. I'm working on OSS project Harbor. Today, I will demonstrate two attractive features of Harbor. One is image replication, another is vulnerability scanning. Okay. The first part is about image replication. With the replication service in Harbor, you can easily replicate the image from the source harbor to the target harbors. The replication is project-based. You need to create a replication role under your project and set the endpoint of the target harbor with your username and password. And here is the target harbor 102. Okay, currently in the project list, only one project in the list. Let's enable the replication role. Once the replication role is enabled, replication job will be created for each of the images under your project. The actual replication work is done by the job. Okay, you can also check the log of the job. Let's navigate to the target harbor. Refresh the project list. Now you can see the project is already replicated and shown in the list. Enter the project, you can see the related image and the tags are already replicated. Okay. So back to the source harbor. Please pay attention here. Currently, the replication role is still enabled. So let's push a new image and see what will happen. We push a new image MySQL 5.6. Okay, a little slow. Okay, it's done. Let's back to the replication page. You refresh the job list. You can see a new job is created for the newly pushed image. Okay, then navigate to the target harbor. Refresh the image list. You can see the newly pushed image already replicated in the target harbor. Okay, that's the replication service in Harbor. Okay, next part is about the vulnerability scanning. Okay, it's a new feature. The vulnerability scanning is powered by OSS Project Clear. The first part I want to talk about the vulnerability database. The scanning is based on the vulnerability metadata. The vulnerability metadata is retrieved from different online CVE repos and stored in the database. Okay, enter your project. If the vulnerability database is not ready, a message type will be shown at the right bottom of the grid folder. The same message will also be shown in the vulnerability tab under configuration. to tip user the scanning database is not ready yet. Once the database is ready, there will be a timestamp to indicate the time of latest database updating. Okay. Also, we can show different timestamp for the different online CVE reports. Okay. Next, let's see how to scan or rescan an image. Find the image you want to scan in your project. Okay. For example, we want to scan the MariaDB. Currently, the image is not scanned yet, so the vulnerability status is not scanned. Click the scan menu under the image, and to start the scanning now, the status is changing in progress. Okay, a little slow. Once the scanning is successfully completed, a bar chart will be shown, and move your mouse on the bar chart, you will see some summary of the scanning. Okay. You can scan the image at any time you want. For example, the Redis is already scanned, but you can still click the scan menu to rescan the image. After scanning, you can see the scan completion time is updated. Okay. You can see all the updated. Okay, let's speed up. If the scanning is failed, you can click the log echo to open the log view. You can see the related scanning log to see what happened during the scanning. For example, there is some root cause maybe recorded in the log. Okay, the next part is how to scan all the images in the system. Before we launch the scan all action, let's check the current status of the image. We can see the current scan completion time is around 22 and 15. The related image, the scan completion time is around 22 and 15. Okay, navigate to the vulnerability tab under configuration. Click the scan now button to launch the scan all action. Scan all is a heavy action. We restrict the frequency of the action, but show a tip to tell user the next available time slot. Back to the image list. Okay, you can see the scanning action is in progress. After a certain while, all the scan completion time will be updated. That means the scanning is, is successfully triggered, and you can see the related summary. Okay, next, the last part is about how to set automatic scan based on policy. Same before we start the next operation, let's check the current status of the image. For example, MariaDB, the scan completion time is 22 o'clock. Navigate to the vulnerability tab under configuration. Set the scan out to daily at 22 and 15. And click the save button to enable the settings. This is a scan policy. Daily at 22 and 15. Navigate to the image list. Because it need to take a while, so after a certain while, you can see the scan completion time will be updated at 22 and 15. All the images, 22 and 16. Because the scanning action itself may take a while, so all the scanning is okay. the automatic scan action is recorded in the API log. So you can also check the log to see, oh, it's already executed. So that's all the feature, the demo. Thank you.
Yeah, thanks everybody joining today's session, vBrownBag session. We hope that has been interesting. Okay, thank you again.